Hello and welcome to the Daily Space for today, Thursday, February 13th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. This week, Twitter and popular media have been full of stories about radio sources that are giving off recurring, oddly patterned signals. The implications of these stories is that these signals are alien civilizations. The tweet that really caught my eye said this particular source has a 16-day period composed of 12 days of silence, followed by 4 days of radio bursts every 2 hours. That super precise kind of weirdness is something I just couldn't figure out as natural. So I decided to go straight to the source. And that source is a preprint posted online by a large collaboration of researchers working with CHIME. In looking at the paper, yes, the radio source is weird, but it is nowhere near as weird as all the alien-assuming articles. There's a lot of them out there, people. So let's take a look at reality. CHIME is a Canadian radio telescope, and we actually have a picture of it that I will pull up for you. CHIME is a Canadian radio telescope that is mapping out the distribution of hydrogen in the sky. This non-steerable telescope studies the sky by literally watching the universe turn overhead. The 4 half-cylinder shaped antenna can see about and process data rapidly. And because there are multiple antennae, it's possible for them to see and validate transient phenomena by noticing when something occurs in all the different antennae simultaneously. This means that the random bursts that come from fast radio burst sources can be seen and confirmed with this particular instrument really effectively. Now, fast radio bursts are weird events that aren't understood, and the majority of them are one-off bursts of unknown origin. And trying to understand these weird bursts is particularly hard because, unlike gamma ray bursts, they don't have a partnered, prolonged, bright optical event that we can use to locate their source and study their evolution. Now, here is where CHIME is able to really shine. Between September 16th, 2018 and October 30th, 2019, CHIME was able to observe repeating bursts from a source cataloged as FRB 180916.J0158 plus 65. Okay, it was awkwardly named, but there's official ways that we do these things. According to the not yet peer-reviewed preprint posted on archive.org, they were able to detect 28 bursts that, and I quote, arrive in an approximately 4-day phase window, with some cycles showing no bursts and some showing multiple bursts. This 4-day window is within a larger 16.35-day period. This source is aligned on the sky with a star-forming region in a nearby spiral galaxy. Now, let's unpack all of that information because this is a radio telescope. This source can be observed pretty much every day, year-round, because the sun doesn't really get in our way. But the only time this particular telescope can observe this source is during the parts of the day during which the source is over the detector. So there are lots and lots of gaps in the data. During the 400 days of observing, they saw 28 bursts. Looking at a plot in their paper, it looks like the detector was observing during 22 of the 25 cycles that occurred during those 400 days. So every 16 days you have a cycle, which means over 400 days, there are 25 possible cycles. During those 25 cycles, 22 of those cycles, the telescope was actually turned on and functional and observing. Now, during those 22 active periods that were observed, they caught 28 bursts. Now, those 28 bursts were during just 12 of the 22 observed cycles. So not every cycle had observed bursts. But here's where I want to clarify that those gaps in the data, because the planet has this super annoying habit of rotating, those gaps in the data were more like, it had gaps that it was able to observe. Turns out this source was only over the telescope for about 12 minutes per day, which means that during those 4-day active periods, they only got 4 12-minute cycles that they were able to see the source. So that was a really small observing window. And so the fact that they caught that many bursts is actually super cool. Now, to understand the system better, the team used this CHIME data to justify getting 3.5 hours straight observing on the European Very Long Baseline Interferometer Network, and an even longer run on the steerable Eiffelberg telescope. Unfortunately, it turns out the wavelengths of light that these radio bursts occur in do not include the wavelengths of light that the Eiffelberg telescope observes in. So that longer period on that telescope, they didn't see anything. This is useful because it tells us what colors of light these sources are occurring in, but it was super annoying. They were able to confirm this was the case because the CHIME telescope was observing at the same time as Eiffelberg, and it saw 2 bursts during that period of time. So, continuous observations aren't something that this team has been able to get so far at a wavelength that can actually see the bursts. Now, when they observed the 28 detections they were able to get all together, they can get a nice, during these 4 days, per 16 days, we see activity kind of data. And using this data and the mathematical equivalent of squinting at the data, they were able to figure out that the bursts are roughly once per hour, give or take half an hour. This is not a rigorously periodic signal, folks. This is an object that is active and has bursts in a noisy way during a window of time that is recurring. This is something that can be imagined to be a binary system. And to quote from the paper, the discovery of a 16.35-day period in a repeating FRB, that's a fast radio burst source, is an important clue to the nature of the object. One possible explanation is orbital motion, with either a stellar or compact object companion. In the author's discussion, they look closely at scenarios involving a neutron star and some kind of a companion star. They can't find a perfect match to what they're observing, but again, not a lot of data. But as they look at this more and more, they will be able to figure this out. I'm pretty confident. And we're also a long ways from understanding neutron stars. So when they say we can't perfectly match what we see right now with various neutron star scenarios, there's also the problem that we don't fully understand neutron stars and their magnetic fields and how all of this might be interacting with a companion star and in the surrounding environment. Now, this is all a super cool source. This preprint on arXiv allows other researchers around the world to know, first of all, who found this cool object, so the original team gets all the credit they deserve. And this also allows teams around the world to follow up and try and get additional data, the kind of data that's needed to understand what is going on. This isn't aliens. The paper shows the burst observations and the spectra. And here I'm going to pull these up so that you can see them as well. And all these different outbursts are slightly different in ways that scream out, no, this is not an intelligent signal. This is just cool science that may allow us to finally figure out what kinds of physics allow fast radio bursts to exist. Once again, this time with feelings, it's not aliens. It's never aliens. At least not until it is. And this isn't that. Okay, so before we end this episode, I have a couple other quick science updates. First of all, there will be another Starlink satellite launch probably this week. And as SpaceX fires off more trains of satellites, the astronomy community is leveling up on their attempts to deal with the resulting streaks of light that you can see in this image from the Dark Energy Survey. The International Astronomical Union has put out a new statement summarizing our current understanding of the impacts these constellations will have on observing. The key new piece of information in this statement, which we'll link to on dailyspace.org, is that the IAU is now going to work with the United Nations Committee for Peaceful Uses of Outer Space to bring, and I quote, the attention of the world government representatives to the threats posed by any new space initiative on astronomy and science in general. So expect new attempts to prevent future satellites from being launched. Anyways, let's end on something happy. In our final story of the day, we would like to point out that tomorrow marks 30 years since Voyager 1 imaged Earth from the outer part of the solar system, allowing us to see our planet as a pale blue dot in the sky. Now, with this 30-year anniversary, these images from Voyager 1 have been reprocessed using modern software. The new image makes it easier to see Earth and is generally just kind of pretty. This was one of the last images taken by Voyager 1 before the cameras were shut down to conserve energy. And yeah, it's kind of cool. Now, if you're thinking, I can't see us, that's because it's like 3 pixels across right here. We're really, really tiny in that image. Again, we're just a pale blue dot out in the universe. And that rounds out our show for today. This has been The Daily Space. I will now hang around and answer your questions live right here on twitch.tv. For those of you watching on YouTube, we record live most Mondays through Fridays at 10 a.m. Pacific. That is 1 p.m. Eastern, 6 p.m. London time. And if you're here live, I can answer your questions. But before I do that, I just want to remind all of you that we are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are produced by Susie Murph, and we are here thanks to the generous contributions of people like you. If you would like to see our show keep going and keep growing, please consider supporting us on patreon.com/CosmoQuestX. This is the best way you can support us, and in return, we will get you all the added content we possibly can. But it's now time to answer your questions. All right, let's see what we have in the chat. And I'm trying to figure out if I have a pretty image to put behind me. And I don't really have anything prettier than that. So we're going to stay with this. So Veronica Kier asks, what color was the signal they were chasing? If you're referring to the radio signature from the CHIME antenna that I talked about at the beginning of the episode, they were looking at the sky in the frequency of hydrogen. Oh, Broken Symmetry, thank you so much for the bits. Let me pull up dog camera. And I'm going to make it rain. Go over there. Go on. Go on. Make it rain. Oh, Malachi, you're so sad. Okay, I'm just going to feed Malachi by hand because he did not understand. He did not understand. And the dogs totally steered the camera. As they ran. Okay, you now have a fluffy butt that you can stare at. All right. So it wasn't 21 centimeters because they were looking at things redshifted, but it was the equivalent of that, but redshifted. When you're trying to look at things in the distant universe, you have to adjust what wavelength of light you're observing at so you can see what color light gets shifted to by the expansion of the universe. Jones, I love your reaction. Hey, guys. Okay, apparently they got a little competitive over a Cheerio over there. So Astro YYZ asks, are fast radio bursts variable? We don't really know yet. So the issue is most of the fast radio bursts we've detected so far have been just like this one random, massive outburst of energy spotted in the radio. Something burped radio signals. And we don't know the cause. There are now, I think we're up to 3 repeating sources where we see periodically from the same place in the sky these bursts. Now, this seems to indicate that this is probably due to something like an inflow of material, similar to what drives cataclysmic variables, where in some cases you get this periodic thwomp. Let's just dump a bunch of stuff on this object and see it go boom. It doesn't explode, it just gives off a burst of radio light. Now, these can be events that occur once every thousands of years, once ever, or it appears in some cases are happening on a recurring basis. These things are far away. We don't really understand all the physics in detail, but we can see ways to get towards stuff like this happening. Do you want more bits? I'm going to make it rain. Go over there. You need to go over there. Go over there. I'm going to make it rain. Make it rain. Okay, they're learning. I am training them to go over there instead of jump on me. These things are important to people. These things are important. Who am I thanking? I'm thanking Wayne Johnson. Thank you, Wayne Johnson. Paranor asks, has Betelgeuse exploded yet? No. Last data I saw, it looks like it's starting to plateau out at a minimum that's a lower minimum than we've previously seen. I haven't looked at last night's data yet, though. So OpenCage5 asks, what kind of number crunching has been done thus far on these signals? Every possible kind of number crunching they can come up with. They literally ran like every statistical analysis you can run on a period object to try and figure out how repetitive are these things, how well do we understand how repetitive they are. So A. McMullen asks, could it be from a pulsar? What's probably happening is there's a neutron star, which is the kind of star that makes up pulsars. This doesn't mean it is a pulsar. It's probably a neutron star with a strong magnetic field that could be a pulsar. And material falls onto it and it goes flare, flare in the radio. So yeah, it could totally be a pulsar. Can't prove it for certain. Astro YYZ says, I'm scared he's going to yank the cord out. I moved the cords around. That's less likely to happen. Larry asks, has anyone seen a OneWeb sat in orbit? I don't know. Goodbye, Jones. Thank you for coming. Oh, that's awesome that you're a longtime podcast listener. Welcome. Thank you, Bad Panda, for the sub. Do you want these? You need to go over there. Go over there. Make it rain. Make it rain. Thank you. Thank you, Jones. I love cute emotes. Yeah, M. Coupon says maybe a neutron star periodically passing through a cloud of dust or gas. Yeah, or it's on an elliptical orbit where during part of its orbit, it steals matter from a companion. There's lots of different ways to get to this. Just none of them fit perfectly to the data. So there's still work to be done. Let's see what other questions. Scrolling. So Henry's River asks, is it possible that the Milky Way had fast radio bursts in the past? Is this just a stage of galaxy formation? So distant galaxies have significantly more star formation going on because they have more stuff still around to form stars. Our own galaxy is only forming like one star per year. And in these much denser, much more rigorously star forming systems, it's possible that we're going to see rare objects at a higher rate because they have more star formation going on, and thus more things that are rare during star formation can occur. So, yeah, it's totally possible we had these in the past and we just don't right now because we don't have enough star formation going on. Cheerios is totally a big deal around here, Jones. I don't know if you're still here, but yeah. Scrolling. Thank you for the bits broken symmetry. Scrolling up. So many good emotes today. Sorry, lots of scrolling to try and find questions. Lots of scrolling. I like that Limprimble is trying to give my dogs a catalog designation. He designates them Pup 003.7R3A7 plus Wolf. My 3 dogs actually all make distinctive barks, which if you're a dog owner is not weird in any way. But Stella actually says arf, 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 arf. So she's not a yapper, she's an arfer. And Malachi has this super deep woof. And Eddie actually barks. So I now understand the origins of all 3 of these words, which has nothing to do with astronomy, but was apparently something I felt you all needed to know. Let's see if we have any more questions in there. Looking for more questions. I love how everyone celebrates Canada. Yes. Okay. So that seems to be all the questions so far. Down at the bottom, I found a new one from M. Chupan, saying, do we think the FRBs we detect are directional like jets? We have no idea. No idea. There's just not enough data to be able to figure it out yet. Okay. And I think that gets us to the end. Yes, we have 3 dog stars here. 3 dog stars. All right. So tomorrow, as has been pointed out in the chat, we will be doing Astronomy Cast shortly after we do the Daily Space. So stay tuned for a double feature. Sometime in the next few days, we are going to actually have another launch of a SpaceX train of Starlinks. So stay tuned to that. If it occurs at a halfway reasonable hour, we will bring it to you live right here on twitch.tv. I keep saying that I have every intention in the world of live streaming while coding. I have no idea if I'm ever going to make it to doing that because I keep getting sidetracked by emails for work. These silly things that actually pay the bills are really complicated sometimes. But that's still a possibility. And I am active on CosmoQuest Discord, working with folks who are interested in helping us with our software and helping us get back to allowing you to do citizen science in new and better ways. So if you're a coder with time on your hands, hit me up. Maybe you can help us code the next bright future for CosmoQuest. All right, that's all I've got for today. And broken symmetry, why did you have to get a brain worm into my head? And yes, Jeremiah was a bullfrog. All right. And yes, Larry, subject-verb agreement is hard. I agree. I am now going to go and make lunch. Thank you all so much for being here. This has been a production of the Planetary Science Institute, a 501c3 nonprofit. That means your donations are tax deductible where law allows. We are dedicated to exploring our solar system and beyond. This episode was written by me, Dr. Pamela Gay, and will be produced by Susie Murph. And we're supported by you. Your bits, your subs, your patronage at patreon.com/CosmoQuestX keep us going. So thanks for all that you do. Now I'm going to attempt to roll the credits, which is always a little bit more difficult than we expect. And wherever you are in the world, have a fabulous morning, evening, afternoon, and I'll see you on the other side. Bye-bye. I'm going to attempt to see you on the other side.